Welcome guys once again. So right now this RAM module, Bayonetta RAM module you can say, is complete. In the sense it is connected to the bus. Not actually to the bus, but you can see this buffer. So this memory address register is connected to the bus, and this buffer, one end of the buffer is connected to the bus. This is the A side. A side is connected to the buffer, and as well as to the one input of 157 74 ls 157, and from this 173, that is memory address register, so q output, that is the output from this register, is connected to the one end of the 157. I see. So we can select in run mode and in program mode. Okay, let's see what happened. So right now it is, this is the run mode and this is the program mode. So you can see the different, oh, addresses. These deep switches are painful when you are no extra nails on your finger. So there is something on the address 1. So let's store something on the address location. So now this is the 0. I just store 1 and check to the location, see, 6. So I just store 1 on the location 6. So now you can see this 1 which is stored into this RAM, and we can also see on this output. Okay, so something you can see, if I make this enable line high, then no data will come through this output, okay, to the bus. And if I make it low, then it will come to the bus. That is the thing. And from the bus, this data can program into the this RAM. We can program into the RAM this same data which is coming out from that bus. So right now it is 1 which is stored into the location 6. So let's see whether it is stored or not. Oh no, something went wrong. See, you can see this thing is happening over here. Somewhere loose connection or something like that. See, somewhere here, somewhere. This is just because the breadboard in one line. So we'll store 0 to the 0, no problem. We store 1 to the location 1. We store 2 to the location 2. This is the 3, location 3. We store 3 to the location 3. So 4 to the location 4. And 5 location 5. So let's test one by one. 0, see, you now there is no 0 on the location 0. Why it is so, I don't know. This is what the problem. Then we'll go to the 1. we are getting the 5, which we don't store anywhere. And then 2 is 2, okay. 3 3, 4 is 4, and 5 is 5. So 0, we don't store 0, location 0, that 4, but I don't know why it is there. So 1 there is also 5, 2 is okay, 2, 3 is 3, and 4 is 4. Okay, no problem. So there is surely a loose connection somewhere. So you can see if I press these wires accordingly, then you will able to see the dot. Now at the location 1, you can see this thing. Okay. Now we'll remove this line, this memory address register lines. Let's test once again what will happen. 0 1 2 7 7 8 8. Let's test. Okay, 0 0 1 1, you can see that. 2, correct. 3 3, correct. 4 4, 5 5, 6 6, okay. 7 8. So it is working properly. Now let's see, these 4 are the least significant bits, okay, and these are the most significant MSB, most significant bits. So what is going on actually here? See, memory address register data from the bus, and this all this data from the bus. So right now I just connected all to the ground, and here is the same thing I have done. I just connected it to the ground. So this is the 4-bit input memory address register, and this is just for sake of understanding what is going on there. This pin, this black pin, is clock for this memory address register. So once we put the data on this side, the data side, and we have to give a clock pulse so that data will come on this side, that is the Q side of this memory address register. And when we are in run mode, so that will selected by this 157, and location, that particular location 0 to 14 location selected with the help of that thing. If I giving the from this side, that bus is feeding the 1 to this memory address register. That 1 with the help of the clock will selected by this 157, and accordingly that location will be selected. Right now we are doing the same thing. You can see it is right now. So these are the least significant 4 bits, so we are using those only, and we'll keep these things grounds, most significant bits. So we are feeding the data into the RAM from the bus. So this is the bus side, this is also the bus side. Okay, the rest of the things are the same. So now I am in the run mode, so this 157 select the data from the bus. Okay, data or address, you can say, whatever coming, because address is feeding into this side, but that address will also come from this RAM also. So it is not that we can say particularly this is the data or address, both from the bus. Make it 0. Now location is 0. This is the manual selection. When we'll enter into the run mode, this will be no longer in use. So let's see what is we are doing here. Let's give the power. Okay, and now into the run mode. Okay, so now this is the location 0, and I am just giving the 0 to that location because all are the zeros, and I'm just giving the 1 to this memory address register. So you can see that 1, this is what I can understand. So now this is not light up, so I just give this clock. Okay, so now this 1 is coming to this Q side and eventually into this selection line. It has been selected, and also I will select 1 over here. This is buffer 1, location 1, data 1, and I just pressing this push button, and that has been stored into this RAM. Now we'll move further. So as soon as you can see that thing, now you can see now I am the location at the location 2, and I'm just giving that 2 with the help of this 2, giving that 2 with this button 2. Okay, now 3. I just want both high. 3. So what happened? Three. And then we will 4. Just give the 4. And last 8. This is what the 8 is. Here also we can go for 8. Now let's test this thing. Remove all these connections and go into the manual mode, and we'll see what will happen. Will show or something not show. Okay, 1. What is this? 2. Okay, 2, 3, good. 4, 4, correct. And 8, areva, it is work. It is program. Nice. 1, 2, 3, 4, and last 8, correct. It is working now.